Hello everyone, welcome to Chemified. I am Pooja Vaishnav and in this video we are going to do solution chapter. In this particular video we are going to learn what is solution and then what are the different types of solutions and the concentration terms or the concentration terms. Clear? So let's move on to our introductory part. What is solution? We come across many different types of solution in our daily life, like salt solution, sugar solution, coffee, tea, juices, soda water, and many more. My question is, you may ask, ma'am, is only liquid solutions are solutions? I will say no, because solution means it's a homogeneous mixture of two or more than two components. Two or more than two components. It can be 3, 4 or 5 and many more components can be present in one particular solution. This is the definition of solution. So, gold, when we go to a jewelry shop, gold jewelry shop, we used to buy a jewelry. Does that jewelry is 100% pure gold? No. What are all the ornaments which are made from the gold are not made of completely pure gold. It has a mixture of any other element. It can be silver, it can be copper, it can be zinc, like that. Clear? So, gold ornaments are also an example of solution. And brass, bronze, they are also the mixture of different metals. So particularly in your NCERT, they may ask what are the composition of brass or what are the composition of bronze. Okay, this is something they have given in the NCERT. So the definition for solution is, it is a homogeneous mixture of two or more than two components. What does this homogeneous means? You may ask. Homogeneous means a mixture which is having a uniform composition, which is having a completely same physical property throughout that mixture. Consider, I'll take an example. I have a juice, orange juice. Here, in this juice, can you say only in this part the sugar is there, only in this part the orange, main orange extract is there? Can you say like that? No, because this solution is completely uniform. If you take a top part or bottom part, the composition is completely same. Clear? So it is called as a homogeneous mixture. Similar, ma'am, give me a heterogeneous mixture example. I will take a glass. In that I have water. I will add some stone particles. So, they are now present here. Now, is this a homogeneous solution? No, because I can say that the top part is completely a liquid and the bottom part I can say the stones are present. So, it is completely non-uniform. So, it is called as a heterogeneous mixture. Now, I believe you have understood what is the meaning of homogeneous mixture. Here in the juice, how many components we have used? Juice extract, like it may be an orange. I have squeezed the orange, I have taken the extract from that and I have added some water to that, some sugar, and to make it little bit sour, I can add a very small amount of salt also. Okay, so here I got 4 to 5 components, right? So is this a solution then? Yes, because from the definition I know that it can be 2 or more than 2 components may be present in the solution. I hope you have understood. Now let's move on to what is aqueous solution. We must know a little bit more about it. Aqueous solution means a solution which has a water. Okay. So let's learn what are the 2 components. In the solution I told 2 components or more than 2 components may be present. In the solution we have solute and another one is solvent. These are the 2 components are present. It can be 1, it must be 1. Solvent is going to be a 1 first component, and the solute can be many solutes we can add. Okay, in the juice I told, or in a salt solution I have a water H2. To that I have added a spoon, 1 spoon of salt. Okay, 1 spoon of salt. And to the same I have added 1 spoon of sugar. Now I got a solution. When I have added all this, I got a solution. Then you may ask, ma'am, which is solvent here and which are solute here? So the water is a solvent. Now this water is a solvent and solute, salt and sugar are the solute. So it means that in the solution, one must be solvent and any other components are considered as solute. So how do we decide, ma'am, which is solute and which is solvent? ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಯಾವುದು solute ಯಾವುದು solvent ಅಂತ? So solvent is a substance which is present in the largest quantity. Largest amount. It is present in largest amount. And solute is present always in a small amount. Then I will take another example. I have a 1 packet of sugar. To this sugar, I have added 1 spoon of honey. 1 spoon, only 1 spoon, okay? 1 spoon of honey. Now, which is solute and which is solvent here? This is sugar is present in the largest amount. So I will consider this as a solvent and honey as a solute. And solvent is always determining the physical state of a solution. This determines the physical state of solution. Means, in this example, the solvent which I have taken is water. This is in liquid form. And when I added this all, I got a solution which is also in a liquid form. So, this solvent is determining the physical state of solution. Are you getting? Solvent decides the physical state of solution. It determines the physical state of solution. Then we'll move on to what is binary solution. What is binary solution? Bi. Bi means 2. Bi means 2. The solution which is made of 2 components is known as binary solution, because bi means 2. A component, B component, we get a solution known as C. So this solution is having only 2 components, so the solution is known as binary solution. If it has a 3 solution, we can call it as trinary, then quaternary, etc. Okay, we must know this much because in the NCERT they have given such. Now, next we are going to move on to concentration terms. Before we move on to concentration terms, we must know what are the types of solution. This is very important. Types of aqueous solution, liquid solution, solid solution. Gaseous solution means the solvent is going to be gas always. In the gaseous solution, the solid is going to be gas always. Solute can be gas, liquid or solid. So we are adding gas in gas. Gas in gas. Where do we see a solution which is a mixture of gas? Solute is also gas and solid is also gas. Air. Air is the best example for gas and gas gaseous solution, because in the air we have many different gases like oxygen, carbon dioxide, nitrogen and many other gases are present. So I'll just write down mixture of oxygen and nitrogen gas is example for gas and gas. Then again, liquid in gas. Liquid in gas. Chloroform, which is a liquid, when it is mixed with nitrogen gas, we get a gaseous solution. Again, solid in gas. Camphor, which is solid, which is mixed with nitrogen gas. Camphor in nitrogen gas is the example for solid in a gas. So now we got the examples for it, for the gaseous solution. Next we will move on to the liquid solution. Here the solid is going to be liquid, and solid can be again gas, liquid and solid. Okay, now you just tell me gas and liquid. Gas in liquid. Gas should be present in the smallest amount, which is present, and the solvent is going to be liquid. Think of it. What could be an example? Yes, in the water, can be in a lake, river, everywhere. Wherever water bodies are there, wherever the fishes used to live, there you can see the oxygen, the air is dissolved in the water. So oxygen dissolved in water. It can be oxygen or many other gases are dissolved in the water actually. Okay. Liquid and liquid. Example. Take any liquid, ethanol or alcohol. Ethanol in water. Ethanol mixed with water is example for liquid and liquid, because ethanol is also liquid and water is also liquid. Solid in liquid. Sugar, water. Alright, glucose plus water. Glucose plus water is example. This is okay. Now let's move on to solid solution. I'll just wrap it out because I don't have a space here. You can note it down. You can make a short note of it. It's going to be very helpful for you. Let's take an example for this. Solid solution means solvent is going to be solid. Solute, it can be gas, liquid, and now tell me, gas in a solid, gas in a solid, gas in a solid. we have example. Solution of H2 in palladium. Palladium is what? It's a solid. Solid. To that we are, H2 is gas. So H2, when it is added to palladium, this palladium is a metal which absorbs the hydrogen, okay, and we get a solid solution. So this is an example for gas in solid. Then we'll move on to liquid in solid. Liquid in solid. So liquid in solid, what could be example? Liquid. When we dissolve a liquid in a solid, we should get a solid solution again. So liquid is mercury. We get amalgam of mercury in sodium. So mercury is what? It is present in a liquid form in the room temperature. When we add this to a sodium metal, we get an amalgam of which is in a solid form. So it's the example for solid solution again. Solid in solid, you know that gold articles, gold jewelry is made up of a mixture which is both are solid itself, right? So gold jewelry, copper in gold, or you can write silver in gold, any other metal. When it is mixed with the gold, we get a gold jewelry, right? So it's a example for solid solution. Fine. Now we got a clear idea about what are the types of solution present. There are many. You can think by yourself, then you can create many more examples for this. In your NCERT also a limited examples they have given. You can think like what could be a, itself you can see many different solutions and think of it which is going to be a solute here and which is going to be a solvent here. Okay. Then we'll move on to concentration terms. So you may ask, ma'am, why do we need to study concentration term? So concentration, what is the meaning of concentration? Here, let's consider I have a 2 glass of water. To 1 glass of water, I have added 1 spoon of salt. To another glass of water, I have added 20 spoons of salt. Now, generally if I see, I can say that the glass which is having 10 spoons of salt is more concentrated than this. This is dilute and this is concentrated, I can say. But can I give a it's not accurate to say, right? So this concentration terms are introduced to know the concentration in an accurate form. We must have some terms which indicates what is the concentration of that particular solution. Even in the lab, we generally use molarity. 1 molar solution, 2 molar solution, 0.5 molar solutions, right? You might have seen that. So let's move on to concentration terms. Concentration terms. Here you have 2 things. One is mass related and another is volume related. I will just make it, I will classify that one before you want to learn about it. Mass related, mass percentage, then molality, mole fraction, ppm, that is parts per million. We'll learn more about it. Just see, it's mass related and volume related are volume percentage, mass by volume percentage, W by D. These are our volume related and these are our mass related. One thing, does the volume changes if we increase or decrease the temperature? Yes. You have taken a glass of water, okay, half glass of water, or else just think about I have taken a beaker of water, to that I am supplying a heat in the water. Does this water expands? Yes, it expands because of heat. So, wherever the volume related concentrations you see, these all are temperature dependent. These all are temperature dependent and these are temperature independent. Independent. Why these all are temperature independent? Wherever you see a solid, mass means mass is generally used for solid, right? By supplying heat to this, does this expand? Is it going to expand in size, or it's not going to change? Temperature is not generally. So they are temperature independent and they are temperature dependent. So in the exam they may ask which are the temperature dependent and which are temperature independent. So let's move deep into mass percentage and stuff. Mass percentage. Mass percentage. It is denoted by W by W. We'll write the formula for this. We'll make it simple. We don't want to make it complex by the definitions and all. Okay, mass percentage. I'll take an example first. 15% of glucose solution. What does this mean? 15%. When do we use percentage? You go to shop, right? Anymore. Consider you went to a clothing store where they have mentioned for this particular day 50% off, and their MRP is 100 rupees. Generally, we don't get a cloth for 100 rupees. Consider if that particular cloth is for 100 rupees and they have mentioned 50% off. Then how much you are going to pay? 50% off means you are going to pay only 50 rupees. Clear? 50% only. In a similar way, if I want to decode this 15% of glucose solution, here I have taken 15 gram of glucose and I have added this to somewhat gram of water and I got a 100 gram of solution. 15% means here it's going to be water, I got a 100 gram of solution. So this is example for this mass percentage. In a similar way, wherever they ask 15% W by W, it means 15 gram of glucose in remaining 95 gram of water, you get a 100 gram of solution. So what is the formula for this? Mass of component divided by total mass of solution into 100, because they have mentioned percentage. This is a formula for mass percentage. It means mass percentage means it's a mass of component to the total mass of solution. Okay. In a similar manner, volume percentage is denoted by V by V. Again, mass of component, this is in gram. Even this is in gram. Volume percentage. Volume of component in ml by total volume of solution into 100. Let's take an example for this volume percentage. %% of ethanol solution. How do we decode this? 15 ml of added to dissolved in water to get 100 ml of solution. So the after adding 10 ml I get 100 ml of solution. This is the way of decoding that particular thing. Okay, you got the example for volume percentage. Next we'll move on to mass by volume percentage. Mass by volume is represented by W by V. Here again the same thing. Mass of component can be solute or solvent divided by, it's in gram, total into 100. It means the mass of the amount of component dissolved to make a total volume of 100 ml of solution. So this will be next comes mole fraction, molarity. This one. What is mole fraction? Mole fraction is denoted by X. It is ratio of number of moles of one component, consider A component, by total number of moles of all the components. This definition and this is the formula for it. N indicates number of moles of A component. I have taken up N B. So what is the definition of this? Mole fraction is a ratio of number of moles of one component, that's A component, to the total number of moles of all the components present in the solution. If I add both the component mole fractions, what happens? Obviously Na divided by Na plus Nb plus Nb divided by Na plus Nb. What happens here? Both are same, so we can write it as Na plus Nb divided by Na plus Nb. And if I cancel this both, I will get our value y. So we know that sum of mole fraction of all the components is equal to 1. Two components. Consider if I had 3 components, then I have to take NC here. NC here. Right, then again I have to find out the mole fraction of C component. Clear? This is the meaning of mole fraction. Then we'll move on to the concentration term, that is molarity. Molarity. Molarity is denoted by capital M. Molarity is number of moles of solute dissolved 1 liter of solution. We have a formula here, N divided by volume in liter. Again, this number of moles, we know that we can write it as mass by molar mass. This is number of moles of solute. So generally we know that solute is always considered as a second component and solvent as a first component. So solvent as a first component. So this is number of moles of solute. So 2. I'm going to write 2. Mass by molar mass, that is for N, and we have volume in liter. Consider if they have given volume in ml, volume of solution in ml, then we know that to convert ml into liter, what we have to do? We have to divide it by 1000. So liter. This is something what I get as a formula. You have to remember this formula. You have to solve a problem based on this. Next concentration term is molality. Molarity, molar.